The sun. In the vast darkness of space, one star reigns supreme, the sun. For billions of years, it has been both the creator and the destroyer of life. The story of the sun begins 4.6 billion years ago. A giant cloud of gas and dust collapsed under its own gravity, igniting a fire that still burns today. From this blazing inferno, the planets were born. Earth itself is a child of the sun. At its core, a relentless process takes place. Nuclear fusion. Hydrogen atoms crash together, fusing into helium, releasing energy beyond imagination. Every sunrise we see on Earth is powered by this eternal fire. But the sun is not calm. Its surface boils with storms larger than Earth itself. Solar flares and coronal mass ejections hurl deadly radiation across space. Sometimes they reach us, shaking our magnetic field, disrupting satellites, and threatening power grids. The same sun that gives us life can also strike us with its wrath. Look closer, and you will see its scars, sunspots, dark magnetic storms that rise and fall in mysterious cycles. Even here on Earth, ancient civilizations recorded strange skies, not knowing the sun's restless heart was the cause. And yet, for all its fury, the sun is our protector. Its warmth keeps our oceans liquid, its light feeds our plants, and through them, us. Without the sun, Earth would be a frozen wasteland, drifting in eternal night. But one day, the sun will change. In about 5 billion years, it will swell into a red giant. Its fire will scorch Mercury, Venus, and perhaps even Earth itself. The oceans will boil, the skies will burn, the creator of life will become its destroyer. And after this violent transformation, the sun will shrink into a white dwarf, a fading ember of what it once was, still glowing, but no longer alive. The sun is not just a star. It is the beating heart of our solar system. It is our past, our present, and our fate. The question is, how long can we dance with fire before it consumes us? Imagine a single ocean of fire so vast it holds 99.86% of everything that orbits it. Imagine a heart that has been beating steadily for 4.6 billion years, giving light, warmth, and life, but also capable of sudden, violent temper. This is our sun, a star, a furnace, and the center of our story. 4.5 billion years ago, in a cloud of dust and gas pulled inward by gravity, our sun was born. A spinning nebula collapsed, most material fell to the center, and ignited a thermonuclear engine. The same cosmic drama that made our sun made the planets, and set the stage for life on Earth. Sun's age and formation summarized from modern stellar models and NASA overviews. The sun is not a solid ball. It is a scorching sphere of plasma, mostly hydrogen and helium. In terms of mass, roughly 3/4 of that mass is hydrogen and about 1/4 helium. Heavier elements are vanishingly rare but crucial, formed in earlier generations of stars and sprinkled into the cloud that birthed our system. This composition is the reason the sun burns the way it does and why it can shine for billions at the core, under pressures and densities almost impossible to imagine. Hydrogen atoms collide and fuse into helium, the proton-proton chain that releases prodigious energy. Temperatures in the core reach around 15 million degrees Celsius, and this fusion powers everything we see: light, heat, and the solar wind. Every second, the sun converts a few million kilograms of mass into pure energy, a staggering transformation that keeps the solar system alive. Move outward and you pass through the radiative zone, then the convection zone, and finally the visible surface, the photosphere. The photosphere is cool compared to the core, about 5,500 degrees Celsius, the layer whose light warms our days. Above it lies the chromosphere, and then the corona, a tenuous outer atmosphere that mysteriously blazes at millions of degrees, far hotter than the surface beneath it. Understanding why the corona is so hot, the coronal heating problem, remains one of modern astrophysics' greatest puzzles. The sun is not calm. Dark sunspots, magnetically charged and cooler than their surroundings, wax and wane with an approximately 11-year cycle. At cycle peaks, we see more sunspots, more flares, and more coronal mass ejections, eruptions that can march through space and disturb satellites, radios, and power grids on Earth. The current solar cycle 25 has been unusually active, and its maximum activity clustered around 2024 to 2025. A reminder that our star's moods can have earthly consequences. Beyond light, the sun blows a constant stream of charged particles, the solar wind, shaping planetary magnetospheres and carving a bubble in interstellar space called the heliosphere. Modern missions are now flying into the sun's realm to learn how the wind is born. NASA's Parker Solar Probe has skimmed closer than any human-made object, sampling the solar atmosphere and giving us unprecedented data about how particles accelerate and how the corona behaves, changing long-held ideas about the sun's outer layers. The sun is our life source, but it is also a laboratory for physics. Studying it teaches us about fusion, the same process humans hope to harness on Earth, about magnetic plasma, and about how stars age. It protects us and threatens us. It made our planet habitable, and it will someday change the destiny of Earth when, billions of years from now, it expands into a red giant. For now, though, it is our steady centerpiece, powerful, complex, and full of stories. So when you step outside and feel the sun on your face, remember, you're touching the result of cosmic events stretched across aeons. The sun is more than light. It is a living star with rhythms, tempers, and secrets we are only beginning to read. Join us as we follow those secrets, from the heart of fusion to the storms of the corona, and learn why the sun remains the greatest storyteller of our sky. The sun gave us life. The cosmos holds our destiny. Be part of this story. Subscribe now, hit the like button, and share this journey, because the universe is waiting for us.